Welcome to Physics Lab. Today we'll be performing an experiment, potentiometer. Now what is it? To find or to compare the EMFs of the two cells, Laplacian and Daniell, by direct method. The apparatus required: eliminator, key K, rheostat, Laplacian cell, Daniell cell, two-way key, galvanometer and the jockey. Now, first let us know what is a Laplacian cell. This is a Laplacian cell. Carbon rod is positive and zinc rod is negative, and the solution is ammonium chloride. Daniell cell, copper rod is positive, zinc rod is negative, copper sulfate is the electrolyte. Laplacian cell, when you make it fresh, its voltage is or EMF is 1.45 volts, in that range, whereas for Daniell cell it is in the range of 1 to 1.1 volt. Laplacian cell gives a little larger current, 250 milliamp current, whereas Daniell cell gives the current in the range of 100 milliamp for the fresh cell. But then why we are using this? Because this Laplacian cell is soon its voltage drains out after little use, whereas Daniell cell, it gives the consistent current for a longer period of time. So these are the two cells, and we are going to find E1 upon E2. By chance, if this is 1.45 and this is really 1.1 or 1 volt, E1 upon E2 will be 1.45 upon 1 volt. So it will become 1.45. But it is not necessary that we are going to get 1.45. It all depends on the cell. Now, let's first connect a primary circuit. In the concept part, I told you there are two circuits, primary and secondary. So first we will learn the primary circuit. So we are starting the connections. This is my eliminator, you can see very well. Positive of the eliminator goes to the A point of the potentiometer. So this is a 4 meter wire. A and B are its end points. This is the binding screw. So we are connecting this to A. The negative goes to the key. From the key it goes to the rheostat. You can see fixed terminal of rheostat and variable terminal of rheostat I have connected to B point. Can you see the connections? By now you are familiar with the electrical experiments and you are very well aware that the connection should be neat, clean and tight. So this is now the primary circuit. Now in this primary circuit, I have kept the voltage at 6 volts. I have kept the voltage at 6 volts. Now, when we are starting the circuit, we have to keep this rheostat position at one end. And then when you put it on, and when you put it on and when you move this like this towards the fixed end, the voltage across this will increase. This part we'll see later on when we perform the experiment. So we have completed the connection of the primary circuit. Now let's see the secondary circuit. This circuit can always be modified. In our concept part, in the first potential concept part, potentiometer, I have told you how to find out the unknown EMF of a cell. So now here we have got two battery cells, Laplacian Daniell. So we are individually finding the EMF of the cell by first taking Laplacian cell into consideration, then Daniell cell. So let's see the connections. Remember one thing, positive of the eliminator, positive of the Laplacian cell and positive of the Daniell cell should be connected all together at the A points. That means all three positives should be here. Whereas negative of the Daniell cell, negative of the Laplacian cell, we are connecting to two opposite terminals of this two-way key. You can see there are 4 binding screws. So we are connecting here. This particular connection, when the galvanometer connection, it should be going to the galvanometer. So remember, the connection should be neat, clean and tight. Then comes this galvanometer comes to this terminal of the key comes to the galvanometer, and from the galvanometer it goes to the jockey. So this jockey you can see, this is the plastic part. So we can hold it. This is a tip, this is metallic tip, and here is the binding screw of the jockey. So we have to take a long wire for the jockey so that we can move it on this whole wire, and then this connections are complete. So this is 1 meter, this is 2 meter, this is 3 meter, and this is 4 meter. So this is our potentiometer. So let's start the experiment. Before that, let me tell you, last experiment which I have shown you in the concept, I had taken one battery cell and showed you how to find the EMF. The same concept is being used here, but here there are two cells. So let's start. I'll revise the connections. Positive of the eliminator, positive of the Laplacian cell, and positive of the Daniell cell, here they all come to a point. Laplacian cell negative comes to this point, comes to this point, both the negatives. And here this goes to the galvanometer and it goes to the jockey. Negative of the eliminator goes to the key. From the key it goes to the fixed terminal of the rheostat, you can see here, and variable goes to the B point. So now we have to start with the experiment. To start with, put on E1. Remember, we know that Laplacian cell EMF is greater than Daniell cell. So always put on E1. E1 is Laplacian. And then put it on. Put on the eliminator. Then I take the jockey in my hand and I need to see what is the potential difference here. You can see that it is 0. Now here also it is 0, meaning it is on one side. So what is your inference? Means voltage drop across this is very less. So you can see that this rheostat is fully here in the picture, full connection. So our whole wire is in the picture. So whatever voltage drop, 6 volts voltage drop, maximum is dropped across the rheostat and very less is dropped across AB. And therefore, in this case, VAB is very, very small, much less than this. And therefore, the current flows from the positive of this cell, goes to the potentiometer wire and then comes here. So, current movement is on one side when I touch here and when I touch here, both are in the same direction. Now what I do, I touch the jockey at the B point, and what I have to do now? I have to increase the voltage drop across this. So how am I to increase it? So I keep on moving the rheostat position so that it moves the other side. So when I touch the jockey point here, A, it is on one side, left side, and this is on the right side. So you see this is what we get. Now that means first time when I touch here, current flows in one direction, and the opposite side when I touch at this point, VAB is greater than EMF of this cell. So current flows in the opposite direction. From here the current flows like this. And therefore this explanation you need to see in the potentiometer concept part 1. Now as we know that at this particular position, from here this 6 volts something is dropped here and maximum is dropped here. Therefore this VAB is greater than E1. Now what I do? I just touch the jockey and I want to find a null point. So this null point I am getting on the 4th wire, I believe. Yes, I am getting the null point on the 4th wire over here. This is my null point. My reading is 1 meter, 2 meter, 3 meter, and from here 3.15. So 1 meter, 2 meter, 3 meter. So the null point I get at that point. Means what? There is no current flowing in this branch. I have explained to you. So I get the null point and this length is 3.15 meter is the L1 length for E1. I am not going to touch this now because we have already adjusted the potential gradient. I take out this and I put it on. Now what is on? Now E2 is on. Daniel cell is on. I take this jockey and tell me one thing. Just pause and try to understand. Where will I get the null point? More than 3 or less than 3 meter? Yes, you are right. The null point I must get on the less length, less than 3. Why? Because this Daniel cell has less EMF than this cell. So let's find out where we get the null point. So I get the null point here. Can you see? So I get the null point here. So the null point is 1 meter, 2 meter and 2.274. 2.274 meter. That is L2. This is the first part. So we have finished taking the first reading. Now we'll go for the second reading. For that I have slightly, this was here, I have slightly changed the position of the rheostat towards the fixed stat. So voltage drop across this has increased. So now that means the potential gradient has increased. And if the potential gradient has increased, definitely we'll get the length for the less value. So let's see, put on E1, touch the jockey here, touch the jockey here. Definitely it is going to move both the sides. And then again find out the length. So second reading I get, here I get the reading. 2.525. Then what I do, I put on this second cell, Daniel cell. I get the reading as 1.85. Then what I do is, I again change this voltage across this. So the voltage drop again increases over here because I have decreased the resistance here. So now the voltage drop is more. Therefore potential gradient will be voltage upon length. So it will increase and therefore again the length is going to decrease. So what I do, I put on E1, take the reading again, it is 2.16 and then I put on E2, I get the reading 1.59. These two readings I get. So altogether I have 3 sets of reading. Let's find the ratio. You know very well, E1 upon E2 is equal to L1 upon L2. So I get these 3 values. So the average I get is 1.37. That is the average. So we have performed the experiment potentiometer and we compared the 2 cells like Laplacian and Daniel. We got the value L1 upon L2 and we got E1 upon E2 is 1.37. Now this is all about this experiment. But one more thing I would like to say, we can always try out different possible combinations of cells and take the readings and learn physics. Physics is very interesting, it is simple and you have to know the concepts well. Thank you very much. Stay tuned to my next experiment and then I sign off. See you once again for the next session. Thank you.